If you saw the 1995 movie The Englishman Who Went Up a Hill But Came Down a Mountain, you might remember this quote. Just a map. Map, my dear, are the undergarments of a country. So, very passionate expression about maps. So the first part of the week we're going to talk about map scale, and then we'll finish up the week talking about map projections. So maps are, I say, usually smaller than the area they represent, but I've never met a map that's exactly the same size as the area it represents. So that amount of reduction is called the map scale. And this tells you the relationship between the distance on the map and the ground distance. So to be an effective map user, it's important to know about the different scale types, how to determine the scale on a map where it might be missing, and it's also important to be able to convert from one scale type to another. So when we talk about map scale, we're always talking about the distance on the map first and how that is represented to the distance on the Earth's surface. So we're going to look at 4 map scale types. The first is the representative fraction, also called the RF, or the ratio scale. A graphic scale, or a bar scale. This is a really common scale that most of you will recognize. The word scale, and then this term of large scale versus small scale. So I'm going to start with the graphic scale or the bar scale because it's a very common scale type. This scale looks like a small ruler, and it's added to maps to simplify distance measuring. So reading a bar scale is easy, and you typically read one from the left of the scale to the right of the scale, starting at the 0. And often the scale bar has an extension to the left of the 0, and that extension uses smaller increments. Now this is an area where beginning map users or novice map users will mismeasure, because if you make a ruler, a paper ruler to measure distance on your map from the end of this line to this line, what students will often see is that's 1 mile. But actually that line distance represents 2 miles. 1 mile here and 1 mile there. So often I'll get students who measure distance and they get half the distance other people get when they're doing that measurement. So be really careful when you look at your map scale that you're actually recording the distances correctly. The bar scale has 3 advantages over the other scale types that we're going to talk about. One is you can enlarge or reduce a map, and the scale will enlarge and reduce with it. So if I were to zoom in on a paper copy or a PDF of the topographic map and print out a section, as long as I print out the scale at the same zoom factor, the scale still works. Or if I reduce it, zoom way out. So that's not something that happens with the representative fraction or the word scale. The second benefit is that the scale is often created as a stacked bar scale, such as the one in the top, so that you can see different units of measurement or use different units of measurements. And then the third is that it's really easy to use to measure distance on a map. If you use the representative fraction or the word scale, you have to do some translation, and with the bar scale you don't. So just to kind of zoom in, here is a graphic scale showing 1 kilometer from the 0 to the right, but then it's showing increments of 100 meters from 0 to the left. And so here is 50 meters, there's another, 500 meters, here's another 500 meters, here's 1,000 meters. So the distance for this entire line is actually 2 kilometers. Another kind of bar scale that you may encounter is called the vertical bar scale, but this is and you may see it on maps where it isn't appropriate, but you'll see it often on maps that have a Mercator projection that are mapping a large distance or a large area. And remember, we watched the video on the Mercator projection and how it distorts the area, or distorts the areas on the northern hemisphere or the southern hemisphere. And so if you're using this bar scale, you need to know what latitude you're using for measurement. So if I'm measuring something around 24 degrees north latitude, this line represents 500 kilometers. If I'm measuring something closer to the pole at 72 degrees latitude, this line would represent 500 kilometers. The second method, scale method, that you need to understand is the representative fraction. It's also called the RF, or the ratio fraction. And this is a representation or a ratio between the map distance, which is always the 1 on the left side of the colon, and the ground distance, which is always on the right side of the colon. So you can also think about this as a fraction, where the 1 is the denominator, or the map distance is the numerator, and the ground distance is the denominator. So if we had a map that was 1 to 100, it would mean that 1 inch on the map is equal to 100 inches on the ground, or 1 foot on the map is equal to 100 feet on the ground. And so representative fractions are unitless. You can add any unit to the left side and the same unit of measurement to the right side of the colon or the ratio, and it still works. So if you're used to measuring in centimeters, you can measure it in centimeters. If you're used to measuring in inches, you can measure in inches, or hand widths, or whatever, length of a pencil, whatever works. And that's the beauty of the representative fraction. So the reduction, another way people talk about it is the reduction is 24,000 to 1 in this example. So when we express that ratio as a fraction, you're talking about the numerator, that map distance, with respect to the denominator, the ground distance. And as with fractions, so if I'm looking at the pi on the left, the 1/4 is a larger number, or a larger fraction, than 1/6. So think about, this gets a little confusing when we start talking about large scale and small scale. So we're looking at the amount of reduction. So if I have a map of 1 to 500 versus a map to 1 to 50,000, the map to 1 to 500 is a much larger fraction. It's closer to 1 to 1. And 1 to 1 would be, the map would be the same size as the ground distance. And the 1 to 50,000 means that there is a lot more reduction. Okay, so that would be a much, much smaller fraction. So the representative fraction for the map in the upper left-hand corner is 1 to 500,000. The representative fraction for the map on the right is 1 to 100,000. So you can see that the map on the right is a larger number. The pieces are larger. The area that's being represented is a lot smaller, but it shows much more detail because I'm zoomed in. In the smaller scale map, which is the smaller fraction, I've got a lot of area shown, but a lot less detail. And so sometimes the term large scale versus small scale or large scale map is used. And this is really a conversation or discussion term. These terms are very relative to each other. There's not a lot of hard and fast rules about where something slips from a large scale to a small scale map. Generally around 1 to 1 million, a continental scale map is considered a small scale map. The U.S. topographic maps that we're using that are 1 to 24,000 is considered a large scale map. So you have to really think about which one has more reduction. So a 1 to 20,000 is a larger scale than a 1 to 40,000. A 1 to 40,000 has more reduction. It's a smaller scale. So sometimes we can use those terms to identify specific maps, and sometimes we use them to talk about one map scale relative to another. The final map scale type that we'll talk about is the word statement, and you'll see these often on a map legend. Sometimes it'll be written out, sometimes it will show, it'll be written like this. Sometimes it'll just be a complete statement, and sometimes it'll use nomenclature as well. So word scales are always stated with when you're finished working with a word statement, it's always with 1 as the map term. If you get a word statement that says 4 inches equal 40 miles, you're not quite finished working with that statement. It should be 1 inch equals 10 miles. If you get one that says 5 inches equals 50 miles, it would be 1 inch equals 10 miles. So it's always good to reduce so that you end up with one unit, and then what that's equivalent to. So you can compare these different types of statements with the representative fraction 1 to 1200. In words, it would be 1 inch to 100 feet, and that would be kind of an engineering plan, and that would be a very large scale map. The topographic maps that we're using, 1 to 24,000 or 1 inch to 2,000 feet, is also a large scale. And then we kind of grade into the aeronautic charts. And then when we get into the continental or the world maps, we're really talking about small scale maps. So those are the different types. And then it's really important to be able to convert back and forth between different map types. So often you will get a word statement, and you want to be able to put that as a representative fraction so that you can get rid of the units and have that as a unitless ratio. So you have to start out by making sure that all of your components are in the same units. So you first have to, in order to remove the units, they have to be the same. So if you have a statement that says, a word statement that says 1 inch equals 4 miles, that needs to be converted to 1 inch equals how many inches. And so what we know is that 1 inch or 12 feet, or 1 foot is 12 inches, and 1 mile is 5,280 feet. And so if you multiply the 4 miles by the number of inches in a foot and then the number of feet in a mile, you will get the number of inches that are equivalent to 4 miles. And because you have 1 in the numerator, and so that's the left side of your ratio, and then your new RF would be 1 to 253,440, and it would not have any units because you just removed them all. So why don't you give it a try? Convert 1 inch to 500 feet, and then convert 3 inches, convert 1 inch equals 500 feet to a ratio scale or an RF scale, and then convert 3 inches equals 24 miles to a ratio scale. Okay, so for the first one, hopefully you paused and did that. So if I take the 500 feet, wait a minute. Okay, that was a typo. So I want to convert feet to inches. There are 12 inches in every foot, so I'm going to multiply 500 times 12, and I have 1 inch equals this many inches. And then I'm going to remove the units because they're the same, and I can do that, and my ratio scale then is 1 to 6,000. For the second one, I have to turn miles to inches, but actually I'm starting out with 3 inches and I want to convert that to 1 inch. So I'm going to say 3 over 3, right? And that's going to equal 1. So I'm just going to set this up as a ratio right now. And then I'm going to do 24 divided by 3. And then I'm going to multiply that times 12 times 5,280 because there are 12 inches in a foot and 5,280 feet in a mile. And if I do that, I'm going to do 24 divided by 3 times 12 times 5,280. Oops, that doesn't equal what I had, so hold on, let me try that again. This is why it's always good to check your math. So I did 24 divided by 3, gave me 8, and then 8 times 12, 96, and 96 times 5,280 gives me that, so that was correct. And that means that my earlier one that I did was incorrect. So my new ratio is 1 to, oh, it didn't like that at all, 50, 506, 880. All right, get rid of that. All right, so that is my new ratio scale. Remember, I need to have 1 to something, so by dividing 3 by 3, I get a 1 on that one. Okay. So sometimes you need to go the other way. You have a representative fraction and you need a word scale. This would be really nice if you have a representative fraction and you want to measure distance. It's hard to do that, to make a ruler. So you could create a word statement and then make a ruler or measuring a graph scale from that. So to do this one, you work it basically backwards, so that I want to convert the 24,000 to miles instead of taking inches and removing my units. I want to add units back. So I'm going to end up with on the left side with 1 inch equals. I'm going to take the 24,000 and divide that by 12 to get feet. Then I'm going to take the 2,000 and divide that by 5,280 to get miles. And that's going to give me 1 inch is equal to 3.78 miles. And if I were doing this on an exam, I would write that, and then I also might write it as a rounded 1 inch equals 0.4 miles. I would show both. So here's one that you can try. Convert the representative fraction 1 to 5 million to a word scale with inches on the left. 1 inch equals some kinds of miles. And I'm going to double check my math while you're working on yours. Whoops. Is that distracting? Nope, I got it right first time. Haha. Okay, so here we go. So what I got on that one, I took 5,000 and divided it by 12. And then I took the value in that cell. That's so easy to do. Watch this. And put that there. Oh, it doesn't like that. Okay. All right. So now I just want to divide that. So I'm going to choose equal that divided by 5,280. And it gives me 78.9. I would definitely round that up to 79. So my answer should be 1 inch equals 79 miles. So you need to be able to work back and forth. Either way that works. Sometimes you will get a map that has no scale. And so there's a couple ways that you can find out what the scale of the map is. So let's say I don't have a scale on my map. If I can find, I can create that scale by measuring something on the earth, on the ground, that I do know that I can get the distance of and set up a ratio. So if I know the distance between 2 points on the ground, I can measure that. And then I can measure that distance between the 2 points on the map and set up a ratio. And again, I've got to make sure everything's in the same unit. So let's say I know that my block is 312 feet on the ground. When I measure it on the map, it's 1/8 of an inch, or 0.125 inches. So I want to convert my 312 feet to inches, so I'm going to multiply that by 12, and then I'm just going to set up that ratio. This is my map distance. Map distance is related to the ground distance, and so then I get an RF of 1 to 29,252. So again, why don't you give it a try? This will also be doing this on the homework, and you'll have this on your exams. So I've got a section of the road, and I'm talking about this section from this section to there. I went out and measured it, and it's 600 feet long. When I measure it on the map, it's 0.3 of an inch. Ugh. And so what I need to know is the scale of the map. So first thing I want to do is convert my feet to inches. So I'm working in the same units. 600 times 12. Okay, so I've got 7,200. Okay, so on the map, so we always put the map on the left side, so I'm going to convert that to that left side of the ratio is 1. And then I'm going to take this, and divide that by the same factor. So let's set that up. Ugh. So I'm going to go equals 7212 divided by 0.3. So the right side of my ratio is 24,000, and the left side of my ratio, forgot the equal sign. Oh, come on, what did I do? Is 10. I forgot to put 0.3. Is 1. So my new ratio is 1. Okay. So that's nice. If I can measure something on the Earth's surface, then I've got it. Okay, so what if I can't measure something on the ground, but I do have a different map where I do know the scale. So if I measure the length of the feature on the unknown map that has no scale, and I measure the length of the feature on a map where I do know the scale, again, I can set up a ratio, and I can use the scale information from the known map. Again, so I'm going to take this needs to be a 1 to something, right? So I'm going to take the known scale, or the known map distance, divided by the known map distance on the left side of my ratio, and set that up as a proportion with the known map distance times the known scale, and divide that by the unknown distance. It's very tricky. So let's see. Ooh, that's really hard to read. Let's tone that down. That's a little better. Okay, so here's the scenario. Somebody has sent me a map, and we're going to go, oh, that's your homework assignment. I won't tell you that. Never mind. So if I measure the distance on my topographic map between these 2 points, and I know the map scale is 1 to 24,000, and when I measure that distance, the distance is 3.6 inches. Okay, so this is what I know. Then I measure between these 2 points on the map that has a scale that I don't know. And the distance is, on the other map, is 2.3 inches. So if the distance is 2.3 inches, I know that the map has more reduction. I know it has more reduction because the distance between those is a lot smaller, so it means I'm covering more area. And if I'm covering more area, the number has got to be greater than on the right side, it's got to be a smaller fraction. So this number is going to be larger than 24,000. So I'm going to set up the formula with the known 3.6 divided by 3.6 on the left side of the ratio, and then 3.6 times the 24,000 and divide that by the unknown distance on the right side. So it's going to look like this. I'm going to take the known distance divided by the known distance to get my 1 value on the left side. Then the known distance times the known scale and divide that here. So 3.6 divided by 3.6, and this is 3.6 times 24,000 divided by 2.3. Remember, everything's in inches, so I don't need to use those units. And then the shrunken map, the scale that the RF that I get is 1 to 37,565. That makes sense because this fraction shows more reduction, and the distance between these two was a lot smaller, meaning that there was more reduction. To a word scale. Let me fix that. All right. So now we want to go the other way. We want to convert from a representative fraction to a word scale. And now that I can, once I have figured out on my map what the representative fraction is, I can take that representative fraction, convert it to a word scale, and now I can make a ruler. So I could draw a ruler that has 1-inch increments, and each increment would be about 6/10 of a mile, and that would be a way to use that back and forth map scale in order to actually measure distance on a map with an unknown scale. The last kind of scale adjustments that you're going to do is to be able to determine which map scale is needed to fit a specific area on a given sized piece of paper. So let's say I want to make a map of Arizona, and I have a piece of paper. I want to print it out on a piece of paper that's 8.5 inches by 11. And I want to use 1/2 inch margin around the paper. So my print area, the finished size, really, I'm going to take 1 inch from each of those measurements. So I really only have 7.5 inches by 10 inches to print my map. So I'm going to go on to Google or to Google and kind of search out how long is Arizona north-south and how wide is Arizona east-west, so I can get the measurements. So now that I see that Arizona is taller north-south than it is east-west, I'm going to use my paper in that portrait orientation. So that means, like, what do people call that? The hot dog rather than the hamburger? I don't remember. But if I were going to, what I'm talking about is that shape, right? Well, or not. Okay, so that's what I'm going to use for my orientation. So I want the 10 inches is going to accommodate the 395 miles, and the 7.5 inches is going to accommodate the 340 miles on my map. So now I have to figure out what is the scale north, south, and east, west, and which one is going to have the most reduction so that both aspects of Arizona can fit. So first I'm going to figure out the north to south scale. And so I know that Arizona is 395 miles north to south. I know that there are 63,000 360 inches in a mile. That's 12 times 5,280. So if I multiply that, I know that Arizona is this many inches from north to south. So I have to fit those inches on 10 inches of paper. And so I'm going to divide the length of Arizona by my 10 inches, and the amount of reduction that has to happen is 1 to 2,502,720. And you know what? I'm going to check the math because it's just a good idea to check the math. Okay, so I've got north to south here. And I have 395 miles. And I want to multiply that. I'm going to convert that to inches. And I want to divide all of that by 10 to see what the reduction has to be. Oh, where's my error? La la la. What did it do anyway? Okay, so let's see if I add commas to that so I can read it easily. Format cell. And I want to add no decimal places but comma separators. Okay, yeah, 2 million, is that what I have here? Cool. All right, so my math is good. So that's the reduction that has to happen north-south. So let's look at the east-west reduction. Okay, so I'm going to just go ahead and check my math here. East, why did we say east first? Huh? Okay, east to west, and equals, let's see, I've only got 340 miles. Oh, I know I need 2 of these. Ha. Okay, 340 miles east-west. And I want to multiply that by, or convert that to inches. So I'm going to go 12 times 5,280. And then I'm going to close that, and I'm going to divide that. I might have one too many parentheses, but we'll figure it out. And then I'm going to divide that by 7.5 inches because that's all I have to work with. Ah, I did it again. Okay. Well, it fixed it. And so now, since I set that column to show the columns, the commas, it helped. Okay, so my math is correct. So now your question is, here is my east-west. Which one of these has the most reduction? And if you chose this one, you are correct. If I were to choose this, not all of Arizona would be able to fit on the width of the paper. It would be hanging over. So I have to choose the map with the smallest fraction, or that has the most reduction when I decide that. And so this is really helpful when I get ready to make my map. I might set my map to 3 million just because that's such a much more even number. And then I would have a little bit of white space around the area and it wouldn't look crowded. So I would go up to that, and that would be my scale. So lots of math and working these formulas out, but basically you need to know that there are 12 inches in a foot and there are 5,280 feet in a mile. And if you want to remember that this times 5,280 gives you that many inches in a mile, that's cool, but it's just as easy just to remember those two elements. So all of these you're going to do in the homework, and all of this will appear on your exams.